Well, welcome to Algebra 2 CP2. I am Mr. Wixer, and I look forward to meeting you in person in a couple days. We will definitely spend our first time together talking all about how the course is going to work, kind of an overview of what we're going to be doing over the course of the year. We'll spend some time on technology and course expectations and all that stuff. But in the meantime, until we actually have a chance to meet together, we are going to start working through our very first unit of Algebra 2. Hopefully you have the unit packet that should have been delivered to you last week if you were in Cohort B. If you don't, you can print out some pages from Google Classroom. The unit packet is posted there. And when I see you in person, I'll make sure you get a hard copy of this. But we are about to start Unit 1, which is an introduction to functions, equations, and number systems. We are going to start on page 3, an introduction to relations and functions. This is page 3 in your packet. As we go through things, if you're watching this video through Edpuzzle, the video is going to pause in certain places to give you a chance to catch up on writing things down. The video might ask you some questions. Please submit your answers. If you get the questions wrong, that's okay. The questions are really just kind of my opportunity to see if you're understanding what's going on or if you're having difficulty and all that. And when we actually see each other in person, we'll definitely spend some time clearing up any issues that you might have had. But as you're going through this, make sure you're taking good notes because you will be submitting your notes to Google Classroom for your participation grade for the day. Section 1.1 is an introduction to these things called relations and functions. We need some place to start. So we're going to start with the definition of a relation, and we're going to say that a relation is a set of ordered pairs. A relation is a set of ordered pairs. A relation is a set of ordered pairs. We'll come back and focus. Wonderful. And I'm pretty sure that doesn't make a whole lot of sense. Let me give you some examples of a relation and how we can show this set of ordered pairs. The first way, I'm going to start with the example, then I'll give you the title for that in a moment. I'm going to write an ordered pair, 1, 4. I'm going to write another ordered pair, -2, 3. I'll write another one, 3, 4. And I'll write another one, 2, 2. Whole bunch of ordered pairs. To show that they're a relation, I need to group them together in a particular way. I need to put fancy-looking set braces around them. And they look like this. Kind of go out, come back in. And now I have a set of ordered pairs, 4 points that I'm going to consider all together at once. This is an example of a relation. I'm going to sort of call this way of showing a relation just listing all the ordered pairs in a set, because that's what I just did. One way I can show this is by listing all the ordered pairs in a set. So take a moment to get that copy down. There are other ways, though, that we can also show relations, these sets of ordered pairs. The second way, well, what's kind of a natural thing to want to do with ordered pairs? Well, hopefully you look at the little hint already shown in number 2. We can graph them. Our second way we can illustrate a relation is by graphing the ordered pairs. Number 2, graphing the ordered pairs. I think you know how to do this. Take a moment, graph those 4 points, and when you're done, do not connect them. Your graph will just be made up of 4 separate non-connected points. Let me actually add that in here. Note. Don't connect the points. Okay, you take a moment, go graph those points. Okay, so let's see, 1, 4, I'm going to go right 1, up 4. Negative 2, 3, left 2, up 3. 3, 4, right 3, up 4. 2, 2, right 2, up 2. And that is my relation. This tells us the same information that it showed in number 1, where we listed the ordered pairs and put them in set braces. That's our second way of showing a relation. The third way we can show a relation is by making a table of values. I'm going to go horizontally with this. You can certainly go vertical as well. I'm going to put my x's in the first row and y's in the second row. To show the point 1, 4, I'll just put a 1 in the row for x, 4 in the row for y. Negative 2, 3 will look like that. 3, 4 will look like that. And 2, 2 will look like that. And once again, what I'm showing in the table shows us the same information that was contained in the graph and contained in that list. We can show this by making a table of values. The fourth way we can show a relation is by making what's called a mapping diagram. And this is probably the least familiar way to you, but it's not going to be a big deal. To make a mapping diagram, I'm going to do an example on the side. I'm going to start by drawing 2 ovals. I'm going to label the first one x, and I'm going to label the second one y. What I then need to do is list all the x values in one oval, the y values in the other, and when I do that, I'm going to put them in numerical order, and I will not repeat values. Let me get all this down. I'm going to list all the x values in one oval, the y values in the other, we will put the values in numerical order, and don't repeat values. Okay, so I'm going to make the video pause for a moment so you can get that copy down. So looking at my x values, I'll get them from the table, but it's the same thing as if I got them from that list up here. Looking at the x values, I've got 1, negative 2, 3, 2. Going in numerical order, I'll do negative 2, then 1, then 3, then 2. Looking at the y values, I have 4, 3, 4, 2. Putting them in numerical order and not repeating the values, I'm going to say 2, 3, 4. The problem is, this does not yet tell us the same information that our table of values, our graph, our list told us. I don't know how the x's and the y's match together. I need to show that by showing how one thing maps to something else. What we're now going to do is draw an arrow from the x value to its y value. We're going to draw an arrow from the x value to its y value. To finish this off, we're going to draw an arrow from the x value to its y value. I have the point 1, 4. I'm going to draw an arrow starting at 1 and going to 4, just like that. Make sure they're not just line segments. Make sure there actually is an arrow at the end, basically to show you we're starting with 1 and you're ending at 4. You take a moment and put the other 3 arrows in there. I'm going to go from -2 to 3, from 3 to 4. Got 2 arrows pointing at 4, that's okay. And from 2 to 3. One other thing I do want to mention here, make sure you are labeling the ovals. Maybe I'll add a little note over here. Label the ovals. I do need you to show these are the x values, those are the y values. These are the 4 different ways we can show a relation. We're going to get a little bit more practice with this, but before we do that, I need to give you 2 more definitions. We're going to turn to page 4. Domain and range. Do you happen to remember from Algebra 1 what domain means? And if the answer is no, that's totally okay. The domain is the set of all x values in the relation. The domain is the set of all x values in the relation. The domain is the set of all x values in the relation. With that in mind, what's the range going to be? The range is the set of all y values in the relation. The range is the set of all y values in the relation. To show these, we're going to list these in numerical order. We will not repeat values, and we'll put them in set braces. So we are going to list them in numerical order. Do not repeat values. And put them in set braces. I'll make the video pause so you can get that copy down, and then we're going to look at a whole bunch of examples of this. Okay, domain is the set of all x values, range is the set of all y values. Let's take a look at letter A. I want to find the domain and range of this particular relation. Well, I do want to label which is which, so I'll just use a D for my domain and an R for the range. My domain is all the x values. 1, 2, 3, 3, 4. I'll put them in order. Actually, I think they're already in order. 1, 2, 3, 3, 4. I am not going to repeat values, so I'm going to write this in set braces as 1, comma 2, comma 3, comma 4. And that's my domain. I'm going to do something similar for the range. I'm going to look at my y values. I've got a 1, 2, 4, and 5. So I'm going to write 1, 2, 4, and 5. Again, in my fancy set braces. And if you're having trouble making those set braces, what I'm okay with you doing is just kind of a squiggly line like that. What I'm not okay with, though, is you using parentheses, because we already saw that parentheses mean something different. Parentheses are used for ordered pairs, or later in the year ordered triples, or ordered other things. We do need set braces, so either these would be best, but if you can't do that, some sort of squiggly line would also work. I would like to see if you can find the domain and range in letter B. When you're done, I want you to enter these answers into Edpuzzle and make sure you include the set braces. You can do that by typing, hold on a minute, by typing Shift, then the bracket on the keyboard next to P. you should be able to get set braces that way. I do want to see set braces, and I do want to see commas in between values. See if you can get your domain and your range for letter B. Well, the domain looks like -3, -2, 0, 5, and our range 4, 6, 7, 4. Okay, we're going to go in order, and we're going to say 4, 6, 7. There we go, domain and range. We can do this from all the other different representations of relations as well, and I don't really think I have to teach you how to do this. I think you can figure this out on your own. So how about you take a look at that graph in letter C and see if you can find the domain and the range, and again, make sure when you're typing this into Edpuzzle for an answer, you're using set braces. Shift the bracket key to get those squiggly set braces. Tell me domain and range for letter C. So your domain, let's see, the x's. Well, I think my first x value is going to be -3. I think the next x value will be -1. Continuing along, I've got x equals 1. And continuing along, I get to an x value of 4. If you're not liking this, I guess we could also write down the points. I've got -3, 1. I've got -1, 4. 1, -2, and 4, -1. As for the range, I'm going to look for the y's. I think the first y value that I see on my graph is -2. As I continue moving up, the next y value that I get is -1. Keep going, I get to a y value of 1, and finally, I get to a y value of 4. And that should be my domain and range. Make sure, again, you've got this in set braces, make sure you're using commas, and all that good stuff. Next one. Letter D. Go find your domain and range and enter those into Edpuzzle. Domain. The x's look like 2, 4, 6, 6, 0. Okay, I think we're going to say 0, 2, 4, 6. And the range, 1, 2, 3, 2, 1. I think the range is going to be 1, 2, 3. And there we go. Letter E. Actually, I think domain and range are going to be easiest when we have a mapping diagram. Find them, and then we'll talk about why I feel like they're so easy. Go find your domain and range for E. Domain, I think, is just the x's. -2, 1, 4, 7. Range is the y's. 1, 3, 5. Why do I feel like this is so easy if you have a mapping diagram? Well, they're already in order. We're already not repeating values. We just really need to read our oval from the top down. That's all we're doing there. And this is how we do domain and range. One or two more things in this video. A special type of relation is called a function. And really, this is what we're going to be spending a good chunk of time this year looking at. A function is a relation where each x value, or input, has only one y value, or output. A function is a relation where each x value, or input, has only one y value. Or output. A function is a specific type of relation where each x value, or input, has only one y value, or output. Take a moment, get that one copied down. And let's see. On the next page, on the top, I have the relation 1, 0, 2, 4, 3, 2. Every x value has only one y value. 1 only has 0. 2 only has 4. 3 only has 2. That makes letter A a function. Letter B. 1 has 0. 2 has 4. But here I've got an issue. 3 has 2. 3 also has 5. Because that one x value had 2 different y values, that makes it not a function. And I guess what we really need to notice is if we repeat x values, not repeating x's, yes, repeating x's. If we repeat x values, we do not have a function. You know what, let me add that into the notes on the bottom of page 5. Actually, why don't we just say cannot repeat x values. We cannot repeat x values. Cannot repeat x values. Okay, turn back to page 6. Tell me, is letter C a function or is it not a function? Well, let's see, 1, 2, 3, 4. 0, 4, ooh, I'm repeating that y value of 2, but that's not an issue. My issue was I can't repeat x's. 1, 2, 3, 4, I'm not repeating x's, so yes, this is a function. Let me show this to you in a couple other ways. Let's take a look at a graph. Let's say I have a point over here, and a point over here, and a point over here. I think that's a function. I would like you, where it says not a function, to copy down those 3 points and then add one more in that would then make it not a function. So I'm going to write this, I'm going to draw that over there, this over there. It's labeled incorrectly. This is a function even though it says not a function. And I want you to put one more point on this graph to make it not a function. I think you could have added in a point with an x value of -2, or an x value of 1, or an x value of 3. I'm going to put another point over here. And now this graph is no longer a function because I have 2 points with an x value of 3. Let's take a look at a mapping diagram. Let's say I have 1, 2, 3, 6, 8, 10. My mapping diagram could look like this. And that's a function. I'm not repeating any x's. I'm going to do the same thing over here with an arrow from 1 to 8, an arrow from 2 to 6, an arrow from 3 to 10. Again, it's labeled wrong right now. This is a function, but I would like you to see if you can do something to this to make it not a function. See what you can do. I think all we need to do is add in another arrow, either from 1 to really anything, or 2 to anything, or 3 to anything. Actually, I take that back. Not 1 to anything. 1 to either 6 or 10. Can't go to 8 because I already went to 8. I'm going to go to 6 and that'll work. 2 could have gone to anything except 6 because I was already going to 6 from 2. So an arrow from 2 to 8 or 2 to 10. Or you could have drawn an arrow from 3 to 6 or an arrow from 3 to 8. Any of those would make it not a function. As long as you have 2 arrows coming out of one x, not a function. Okay, almost there with this video. One last thing. On the next page, there's a little test for a graph to tell if a graph represents a function or not. And this test, you probably remember this term from Algebra 1, is called the vertical line test. What this says is we're going to slide a vertical line across your graph. Slide a vertical line across your graph, and we'll slide it across horizontally. If that line ever hits more than 1 point at the same time, we do not have a function. If it ever hits more than 1 point at a time, or at the same time, it is not a function. I'll make the video pause, get that copied down. So if we go back to the previous page, if I take a vertical line, let's see, what can I use here? Oh, I'll just use my pencil. If I take a vertical line and I slide it across that graph, it's hitting a point, fine. Hitting a point, fine. Hitting a point, fine. It's a function because it only hit 1 point at a time. But over here, if I slide my vertical line horizontally across my graph, hitting a point, fine. Hitting a point, fine. Oh, here's my problem. Hitting 2 points at the same time, which means it is no longer a function. With that in mind, I'd like to see if you can deal with these two examples. Is this first one a function or not a function? And if you can't just see it, actually take a vertical line like your pencil and slide it across your graph and see what happens. First one, function or not a function? I think the answer should be function. I don't think we ever hit 2 points at the same time. That's a function. Over here, slide a vertical line across there. Hitting 1 point, fine. Hitting 2 points, oh, that's an issue. Not a function. And I think that's all I have to say. These videos will always end with me asking you if there are any questions that you have. Please do send questions to me through there, and I'll kind of respond to them through Edpuzzle, and you can go in after I've taken a look at things and see my response to try to clarify any questions that you might have with this.